And I was thinking that, our overall population is any hitter that goes into the major leagues over 6 foot or equal to or above or whatever. So,
Yeah.
That way, even if we grab all the data from the wild card era to today, or actually through 2015 or whatever, we still have, that's still a sample size, and then we still have a greater population because we always knew that was at least, does that make sense? That was something I thought.
Yeah, that actually makes perfect sense.
And I think since the season just finished too, the database I have only goes through 2016. So it would be, I'm going to try to do the, like I said, the wild card era to 2016. So we won't have 2017's data. So that'll be new, and then any future hitter over 6 foot should be that.
Yeah, that'll be perfect.
Cool.
Okay, so we just have a very light. Well,
hang on one quick second. I just need to answer this real quick.
Okay.
There you go. Yeah, no, I think we're good, and you have dinner. We have dinner done. So. All right, sounds good. All right, thanks. Oakley dokley. So let's share our screen. This is just a review, right? If I remember right.
Yeah, the review for the test.
And when does the exam open tomorrow, or is it already open?
Tonight at 10.
Yeah, and it's only through Wednesday night.
Oh, that's a short time.
Wow.
Yeah.
You look happy about that, Sam.
Oh, I'm super excited.
Don't you love how on-campus students get this week off and we get to do homework?
I know, and it's like they think that we have so much free time, but it's like we're all working, and some of us have kids. I don't, but
Yeah.
It's like everyone has things going on. That's why we're studying online.
Yeah, right. It's the exact opposite of having free time.
Yeah, it's not easy when you're. They think that, like, my mother-in-law think they were up here for my son's piano recital over the weekend. She think that I'm at home. That my house needs to be spick and span. I just like, your son. I have your son in my house,
Yeah.
And I'm studying. I got 4 classes to study, to work on, and as you get older, your brain is not as flexible as you used to be. So.
I don't know. My wife and I, it's like we have we have 4 boys, and our house is not clean very often. We are not.
Yeah, when you have kids, you cannot expect a clean house.
Yeah, but we're not neat freak people. But the other thing that, to me is like, would I love a perfectly clean house? Sure. But it's like, what are my kids going to remember when they grow up? Are they going to remember a perfectly clean house? Or are they going to remember that we went to their sports activity, their concert, their whatever? So to me, I'd rather have a dirty house within reason. I mean, I don't want to get my kids taken away. It's so dirty or anything, but it's like, who cares if the floor's mopped, or you go spend time with your kids, and that's way more important.
Yeah.
So.
Yeah, and they're just like, I grew up with how many? We're 9 kids in the family, and our house never stayed. It's clean to the, not the meticulously clean, but you have kids. You got socks will be laying down on the floor, toys all over the place, and I try to train my son. He's 10 years old. I'm trying to train him as much as I could, but there's so much you can have the child do. So.
Oh yeah, for sure.
So yeah. So anyways, yeah. So there's so many things that they expect that you're an online student, that it's easier than going to the class. I think it's easier to go to the classroom than having it online, because at least there's a teacher talking talking and discussing the lesson, than you sitting there for hours and hours reading through, going through the readings.
Yeah. Trying to figure it out yourself.
So, anyways.
Okay, well, I know the answer to number 1. I'm good. So this exam should be since exam 2, right? Which hasn't been that long. Or does this have like, right? I don't think this goes back too far.
Yeah, this is fairly recent.
Yeah, they've been trying to combine things. Have you guys finished reading, going through the recording that they sent out over the weekend?
I have not.
I was partially doing it, and I was reviewing. I'm going back to different videos of our class. The online thing. I'm doing chapter by chapter quick review. So.
Well, you've been studying harder than I have. I haven't had time.
Yeah, this morning I was just like bummed out because my mother-in-law just when my husband is not around, that's when she's trying to get on me. I just like, seriously. And then my husband came home with a letter from his principal, and just like, nope, you're not signing this one.
Yeah.
So, but there's still a lot to be grateful for, even though we're surrounded with rotten core people. So, anyways. Okay, this one.
Is this an ANOVA test? Or am I just hope? Well, or wait, we're past ANOVA, aren't we?
No, this is just a review pretty much of all what we've learned.
I think it would be ANOVA, wouldn't it? Because it has so many things, or no? Or is it the...
Is it the chi squared, or is it ANOVA, I guess?
It's one of the other, and now I'm not sure. Determine if, it's independent. So I think it might be the chi.
The chi square thing?
Because you want to determine if it's independent.
So you wanted to determine.
But I could be wrong.
Well, chi was in this since the last exam. If we were doing ANOVA, that's like back previous. So I don't know if that's.
Yeah, and the ANOVA I think was more like number stuff, and the chi squared test of independence was like testing weird things that aren't like number based.
Hold on, let me see.
I think that's the official weird
categorical.
Thing.
I think that's what it said in the textbook.
Yeah, weird things.
Yeah, weird things that aren't number based.
So if it's not categorical, if it is not quantitative, it's categorical. So if it's categorical, that's a chi-square or chi-square, whatever you call it.
Yeah. Categorical / weird stuff.
Exactly. I should be a statistics teacher.
You should. So you better tutor us.
You have a new what's the word I'm looking for? You have a new goal in life, right?
Yes, that is what I want to do, is be a statistic teacher.
Yeah. All right, so we're good with that. Number trace.
Factors illegal to discriminate against employees because of age. Also report the number of employees in each group were terminated.
Your group's 40 years old.
Oh boy.
The number of employees in each group. So this is like it's either a paired sample t-test or independent sample t-test.
I don't have any idea.
We're ready for it.
Yeah, I think I'm ready for this test. So we're comparing two different things, right?
There's a group, two groups. So we need to age
discrimination.
Older and younger group.
And then both ages were treated equally. Okay.
So are they dependent or independent with each other, the two groups? So.
Or would it be a proportions test?
Okay, let me see. So there's two people, two groups. That's proportion test under categorical type. Let's see.
I don't know.
So that's a test of two proportion because
I was wondering, but I don't know.
it's, let's see, where's my
Yeah, I'm
lesson?
also confused right now.
What lesson is that two test proportion? That's 18?
It was recent, so it would be around there.
Yeah, lesson 18. So were they treated differently, yes or no? And then they got male and female, or younger and older. So I think that is two test proportion.
Like, the two test proportion, one of the examples was can male or female taste PTC?
Uh-huh.
I mean, there's like the yes and no, and then in this one, there's like were they terminated or not terminated, and it's
kind of
over 40 and under 40.
Uh-huh.
So I mean, it's kind of the same idea.
Uh-huh.
I don't really know.
Because it's either they're terminated or not.
Yeah.
If their age falls into either they're younger or older,
So do we want to go with the test of two proportions then?
What about you, Brad?
I'm lost, so I believe you. Yes. I think the two proportions is the one.
Well, at least you can try it 3 times. There's 3 of us.
We're just looking at, you realize like the first 8 questions are all these kind of questions. So we're going to have to figure it out by the end of it. Oh,
yeah, which means it's going to be on the test too.
Well, unless it's like last time, then this won't be on the test.
Oh, yeah.
Well, it might be on the test about word differently. Yeah. So.
Survey was conducted by a group of state. So do we want to go with that one and move on, and then we'll see what happens?
Yeah.
Okay. 2, 4, 6, survey total 248 classified as heavy players.
Goodness gracious.
Proportion male height. Would that be a test of one proportion?
Yeah, because they just mentioned one male at the male.
Mm-hmm. Well, heavy male.
Heavy male, yeah.
I feel like that would be a test of one proportion.
Uh-huh.
Let's keep moving. Else we're never getting through this thing. Okay.
Wow, my goodness, there's a lot of them.
Students will participate in the study. Each student is going to come each teach log out at the first time. It's time to open each letter is recorded. Would that be like an independent sample test?
We have 2 locks and you're essentially seeing which one's better, right?
Mm-hmm.
Yeah.
So
wouldn't that be a paired sample t-test, or am I?
Oh yeah, I guess you're right, because when you pick one lock, then the second lock has to be the other direction. So that would make them paired, because the first one determines the second one.
Okay, let's start there. We can always test. The next 3 identify the one confidence interval that most appropriate for the given situation.
It employs 2 appraisers on improving and the same types of properties consistent to make sure this is the case. The bank validates 6 properties that both appraisers and evaluate which confidence interval would be the most appropriate for the study. Oh my gosh. I wonder what they think when they listen to our videos.
They might say this group is just the whiners. Okay. Appearance example, okay, what was asked again? A bank employees to appraiser. So they're valuing the same type of properties consistently. So to make sure this is the case, the bank evaluates 6 properties that both appraised had recently valued. Confidence interval. So talking about confidence interval, that would fall under an independent or.
So there's 2 appraisers, so would that make it a confidence interval for 2 proportions?
Well,
There's 2
or would it be
appraisers.
a paired sample because it has to be something that they both had recently valued?
Yeah, because there's 2 appraiser and they're valuing the same type of property.
Oh, so you're saying it'd be 1 proportion?
To make sure that the case the bank evaluates 6 properties. So when proving.
I think it's a paired samples T confidence interval, maybe?
I was wondering that because all of the properties are ones that both of them have but then at the same time I don't know because I mean they're still the same properties, but I guess they might be.
I think it's a paired
different.
T. I'm pretty sure it's paired T. Let's move
Okay.
on. Paired T on that one. So Wall Street Journal article is career pass, percentage of psychology majors. Satisfied, you decide. 95% confidence interval. See slides. Which confidence interval? Okay.
Percentage of psychology majors reported. Same data was also reported for accounting majors.
What did you circle there? That
Would it be independent?
1 sample t-test or hold on. Independent sample t-test interval?
I felt like I knew these really well, and I don't think I do.
Sample C, sample t-test. So confidence interval. So let me check.
Oh, we're going with satisfied. So would it either maybe be the confidence interval for 2 proportions?
So observe difference.
But they're.
Which one did we do with the difference?
Sample T confidence because we don't have it's not the Z because we don't know we don't know the standard deviation. And it's just a single confidence thing. Are they satisfied or are they not? It's not.
So which one is that we did the
there's 2 different groups that we're looking at, right?
Is there? No, it's just the psychology majors. Are they satisfied? Yes or no?
Oh, the same data we're also.
We're still on 7, right?
Oh, the accounting majors.
But there's the psychology, and then the same data was reported for accounting.
Oh, I'm sorry. There was that. Hold on a second.
They're talking about the difference of significance.
So would it be paired then?
Paired sample t-test. Yeah. You're right. Sorry, my bad. Double stuffed Oreo.
That's too much sweetness there. Double stuff.
This one's a single T. There we go. I think that one's single T because you're just looking at.
Okay. Number 9.
What did we do? We did paired sample T-test for 7.
Yeah, that's what we said.
I don't think that's right. I just thought of something. Because they're not paired because it doesn't matter. The accounting major doesn't rely on the psychology major whether they're satisfied. I think it would be the confidence interval for 2.
Okay.
Wouldn't it? Because paired assumes that they're.
That was one of the ones I was guessing, but I wasn't sure.
No, I think that one's sorry. That just popped in my head. But I think that's confident, and then I think this is one sample T with a double stuffed.
So number.
So 7 is the last confidence interval for 2, and then 8 is B.
So number 6 is paired, right? And 7 is the last one.
Yep. And then
Yeah,
I have 8 is the second one.
Okay.
And now we're out of those. Yay!
It will come up in the test.
Which one of the following best defines the notion of the significance level of the hypothesis test? Excuse me.
The notion, the probability of surveillance.
So I don't think it's the type 1 or type 2 error.
It's A. The significance test of the level of hypothesis is the probability of observing a sample statistics. It's like the p-value kind of type thing.
Is it not the type 1 error? I thought this one was a type. I thought we had this question before. I could be wrong. Wouldn't be the first.
I mean, the probability of having a type 1 error is when the significance level is bigger, and the probability of a type 2 error is when the significance level is smaller. But I don't feel like that has to do with like the actual value like the
statistical.
I don't know. I mean, it could be that, but I don't know. I don't know how to explain what I'm thinking.
I could be 100% wrong too. I'm just.
Well, which of the following best defines the notion of the significance level of the hypothesis test? The probability of rejecting.
Let's see.
The probability of the type 2 error. So defines the notion of significance level of hypothesis test. I thought I just read that earlier.
So I'm looking up online, and it's saying the significance level, also denoted as alpha, is the probability of rejecting the null hypothesis when it is true.
When it
So
is true,
that would be the probability of a type 1 error. Isn't that what the type 1 error is?
I think so.
When you reject when it's true. So you were right, Bradley. I think it's the probability of a type 1 error.
Okay.
I maybe.
I remember having that question before. That's why. Okay, we'll keep moving. Which of the following best defines the notion of the p-value of the hypothesis test? This one's sort of similar but different. Now it's about the p-value.
Definition of...
That's the last one, isn't it? Hold on, I got it confused. Hold on. The camera is not thinking.
This one is
You're
the
good.
probability of finding the observed or more extreme results when the null hypothesis is true.
It's true. Yeah, that's what it is about my p value I read earlier.
So it's the third one?
Yep.
Yeah.
Well, we've answered this question like 55 times, and it always makes my brain hurt when I think about this next question.
¿Qué temperatura?
Mercy.
Uy. I'm told to report this by saying
I swear we've done this one. 90. Isn't it like 95% of all the 95% confidence interval of the true mean? The B.
Well, it's not the first and third one.
Not the last one either.
I think it's the second one. Yeah.
Bravo.
Because I remember the TA said if there's a chance in the thing, in the statement and the data, that's not the right one.
Right. Take a simple random sample of 100 adults. In the unpopulated portion, 0.3. What is the mean of the distribution of the sample proportion?
Okay. You take a sample random.
One of our Excel sheets, I'm assuming.
P is equals to 300.
This would be the one proportion thing, right?
Let's see. Oh.
But I don't. Assume the non-proportional improvement. The stock said P equals 0.3 or 30%.
So 100. Others in town. P3. Okay. Which one is this one? Let's see. That's not one second. Yes. Not that one. Plot histogram now. I'm missing one. So which one is this one?
Is it the one proportion? But I don't know what the P does.
That's what I'm trying to figure out here.
Because I thought the P was just the value over the number, which the number is 100. So
So the mean of the distribution of the sample, let's see, P hat.
P divided by where's my 0.30.
Because this one's like
0.30 divide 100
times. 0.3. Isn't this the one that's like P? Oh,
P hat over the N?
It's like P hat times 1 minus P hat over N. Remember that one that I'm looking at some of my notes, and it's, of course, my handwriting's too bad to really make sense of this.
So, well, it's the P hat is equals to X divided by N.
Right, but P and P hat are the same, aren't they? More or less.
Yeah, pretty much.
With this information, we don't really know much, so isn't it? I think they're the same.
Uh-huh.
Would that? Hold on. Let me put this through my little calculator here.
Whoa, what is that?
Okay, so I think I got this. So wouldn't you put in it's the same one proportion? You put X is 30, N is 100.
Mm-hmm.
Right. So then the P hat is 0.3. Like this, I think the number 12 is 0.3. And then the standard deviation I have is 0.046. And the probability that your random sample of 100 adults will have the sample portion of less than 0.25. Does it say less than?
Yeah.
Less than 0.25.
That one I'm not sure what I do here.
What is the standard deviation? And then what is the probability that the random sample of 100? A sample proportion. So sample proportion is...
Oh, then we use the Z-score, don't we, on this one?
Probably. To put it in the applet?
Yeah.
Yeah. What lesson is that Z-score?
Trying to
Lesson 5.
Goodness, if I have a Z-score of 1.8. Oh, that doesn't make sense.
67.
I'm confused.
Okay, let's see. Not that one. The X is Yo. Sample proportion is P is equals to, hey, that's the number.
I'm lost on this last part.
Yeah, just a minute. P is proportion P. Point estimate of P. is the NP is equal equals or greater than 10?
No, saying that less than 0.25. Six.
So it's that the both side of the end of this. Oh, no, that's not it.
Well, just be the left side, wouldn't it?
Huh?
Wouldn't it just be the left
If
side?
it's less, it's the left side.
Yeah.
Yeah.
Oh, hold on. I think I have. So I have the z-score. So z-score of negative 1.09. Let me try to plug that in real quick, and then we're doing less than, right?
Yeah.
Mm-hmm. What's the z-score?
I have negative 1.09. And that would give me a
0.1379.
0.138, right? If we round it.
Mm-hmm.
Okay. I think that's, I don't know, close, right? Maybe. I guess we'll find out. So if you do like, because that's like the, so what I did was like the 0.25 minus the 0.3 over the, whatchamacallit. So I did the, 0.25 minus 0.3 over.
You gotta put 0 in front of that 0.3.
What?
You gotta put 0.3.
Right. Oh, this, yeah.
Uh-huh. Yeah.
But so I did 0.25 minus 0.3 over the standard deviation, which gave me the negative 1.09. So that's where then I put that into the thing. So that's where I got that. Okay.
Okay.
We'll move on. We'll see if I'm right. Okay, let's look at this next part. Margin of error at the 95% interval. Okay.
This is the 2. Which one is that one?
Just the two
The
proportion.
proportion. Yeah, the x1, n1, x2.
So
Same.
So what was the first question? Margin of error.
So x1 is, so if we have two groups, 1500, so 1563, hold on. Is that N1, 1563?
Hold on, let me finish the control group receiver placebo.
Yeah, that would be N1. I think. The N1 or N2, but I would guess it would be N1.
Yeah. So the x1 is
61.
61. And that's 1563 N1. The x2 is 15.
Yeah.
And N2, is that 579?
579.
Okay, let's see the control.
Cannot type today. My goodness.
Cause yeah.
Create a 95% interval.
The margin of error, did you guys get 0.016?
Hold on. Where's my cursor?
Hold on 1 second. Yeah, 0.016. Yeah.
How did you get that? Where did you get that?
That's let's see, 23. I made a I put it in my
Margin of error.
I put it in my Excel sheet. So I had,
How do you do that?
P2 minus P1, which is 0.032, and then divide that by 2, which is 0.016.
Okay.
So lower bound is negative 0.003. Upper bound is 0.029. Perform a hypothesis test. See if this proportion of the experiment group subjects is different from the controls. Use a significant level of 0.05. What are the appropriate null and alternative hypotheses? So our p-value is 0.9, so we're definitely above, but I guess that's not really what it's asking. It's saying experience isn't different, so it's equal and not equal to, for sure, right? So it'd have to be, is it A or the top one?
Hold on. So,
Or is it, it's either A or E, A or E.
so our p-value is 14.
No, our p-value is
145.
0.9 to 8, right?
What are we asking about?
18, though, 18 is that, it's either A or E, but I think it's E, isn't it?
I want to say it was the weird one on these. So yeah, I think it's E.
Because they're asking, are they different? So the different would be the question, and then it's saying they are not different would be the alternative.
I think so, yeah.
So that's the last second to the last one?
Correct. And then the test statistic, which one is that again? I always get this confused. Is that
Test statistic is the
the p-value?
The Z.
The Z, 1.458.
Uh-huh.
And the P is 0.928.
Oh,
Oh, I got
That's what I
0.145.
What is your type of test?
I just have less than or equal to, so we need, I need to change that, huh? Oops, sorry. 0.145.
That's what I have.
That's what I have too.
My bad. Thank you.
So that means your does it change your margin of error?
No.
It shouldn't, because I had the same thing.
Yeah,
So,
no, the only thing that changes is the p-value.
So tell me again, how do you get the margin of error? It's P1 minus P2.
So let me bring my spreadsheet over real quick. See.
Okay.
So can you read that, or should I blow that up a little bit?
Uh-huh.
That better?
Yep.
So this is the difference. So I do this minus that. So the difference between that is 0.032. So that's the difference. Divide that by 2 gives you your margin of error.
Okay. So it's the confidence interval.
You want to go that, yeah. So that's your margin of error.
Okay.
What is the point estimator? What's that?
I don't remember.
It's, it's the p hat minus p hat 1 minus p hat 2. The top one.
Oh yeah. So I have C16 minus. So I have C16. So C. Yeah,
that one.
P hat minus P hat 2. Yeah. So point estimator. I don't remember what, but I put that in my little thing. So.
Thank you so much.
21. Is there sufficient evidence to conclude that the true proportion of people who experience dysnosis will take blah, blah, blah is different than those who do not? So we had a p-value above
the
alpha.
145. So we failed to reject
the H0. So
A, B, C, D.
I failed to reject HO.
Well, but is it this or is it no? Yes or no? So I guess.
Or no. I failed to reject HO. So the last one, right?
Well, but is it? But what's the answer to the question? Is there sufficient?
Oh.
That's what I'm saying. So we have to read the question. So it's saying, is there sufficient evidence to conclude that experienced dizziness is different?
Yes. Because it's higher.
So what? Hold on a second. Let's go back here. So if we said, so we're failing to reject, so we're keeping this. So we're saying it's different, right? So the question originally was that. So they expect them to be different. So we say, are they different? So yeah, I guess yes. Failed to reject, right? So it would be the middle one, or the. D,
D.
not the last one, right? I think that's right. Why did I not save 18? 18. Okay, 20. Everyone's good with yes, I failed to reject HO?
Yes.
Okay. Now, calculate the test statistics. So this should now be to the chi-squared, correct?
Yeah, this is.
Okay, so let's fill it out. 97, 131. This does not have totals, so you put in all the numbers, right?
Yeah, don't put the total or else it will
But this one doesn't have totals, so we just
okay.
put it out, right?
Just everything that they have there.
Okay, so calculate the test statistic, assume that the requirements of the test are satisfied. So test statistic 6.579, is that what everyone got?
Hold on, I'm still inputting everything.
Yeah, just a minute.
Okay, so what was our question? Calculate test statistic.
Test statistic and then p-value.
What did you say you got?
6.579.
That wasn't what I got. Oh, I'm looking at the wrong. No.
Hold on,
There's one called test statistic, right?
Yeah.
131.
Wondering if I put something wrong.
Unless I put something in wrong. It shows.
So the test is this 6.7579.
That's what I got, yeah.
What did I put in wrong?
You have to put them in the row or the morning. The top row is the morning person, and evening person, and then you have 4 columns.
You can look at mine. I have mine up if you want to peek at it.
97, 131, 137, 137, 210, 200. So why is mine weird?
To make sure you deleted all your rows and everything, or you didn't delete any.
Okay, well that's where it's coming up weird. Oh, 90. I put 91 and I saw 97.
There you go.
There we go. I have the same thing now.
All right, and then p-value we got 0.087.
Yep.
Should you reject HO or not?
So
P-value is 0.08, which is above, so we should fail to reject. So we should say no. So no, the p-value is greater than 0.05.
the bottom one. Oh no, not quite the bottom.
No, the middle one, the D, delta.
Yeah, yeah.
That look good, Sam? Holy cow, we're not even like halfway done yet, are we? Or we're right around halfway.
We're 25, number 25.
Based on your results. So p-value is greater. And
B.
so we have insufficient evidence that it's independent.
Oh, it's not independent of age. It's either at D. What we have in no. Hold on. We have sufficient evidence to say that being a morning, evening person or evening person is not independent of age.
Would it be?
A.
Wouldn't it be C? Because the null is it is independent, and we have insufficient evidence, so we don't know if it's independent. We have insufficient evidence to say that it is independent, right?
So it's not independent of age. So it's the D at the bottom one, then the D.
The HO is being a morning person or evening person is independent of age. So, and we're failing to reject. So we're agreeing with that.
So it's not.
We have insufficient evidence to say that it's not independent.
Mm-hmm.
Yeah, that's right. Yeah.
Remember last week
yeah.
we did the it's not thing.
Delta, but the last.
Uh-huh. Yeah.
Use the following information for the next 8 questions. You book noted 20% of all investment managers outperform the Dow Jones Industrial. No, they don't. A random sample 200.
So we're doing.
You okay?
So our N is 200.
So which one is this? One portion?
One proportion.
So we're saying 200, and then our X is 50.
Hold on. The 20%. 20%.
Well, so yeah, which is 50, right? Or no, that's 25%, isn't it? It said 50 of these outperform the Dow Jones Industrial Average.
Okay, 20% of 200.
That P. Oh, I said P is the true proportion.
Hold on. I had a graduate top 10 business. Oh, the 50. I didn't see the word 50 there. My bad. Outperform again. So, and what is the question below?
That's for the lower and the upper bound.
So,
But it's
the
saying
95%.
P, but it says let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Industrial. But
So, you put the so your N is, your X is the 50, right?
I think so, but I'm not sure.
To me, so above it says that it's 20%. 20% of 200 is not 50.
It's 40.
But then it says let P be the true proportion of the investment managers. So it's not. I wonder if that's is that like a trick question there, where it shouldn't be 50, it should be 40.
I think it's the 50. It's 50 of this outperformed the Dow Jones Industrial Average. So,
Right, I get that. But what's this? Let P be the true proportion of investment, and then below it says we're doing the confidence interval of P.
So the P is let's do the P is what is that? X over N.
So I think that maybe the P part is going to come into play in question 28 when we're deciding what the sample size should have been in the experiment or observation.
But for now, you use 50 as your X. Is that right?
I think. Because I think what they're telling us in question 28 is that the sample size of 200 was not what they should have done. If I'm reading 28 correctly.
So 28.
So we should do it with a 20. So we should do it with a 50.
I think for 26 and 27, I think it's just still with the 50.
Okay, so the lower bound would be 0.190, and the upper bound would be 0.310. And then suppose you've been charged with the study, what sample size would be needed to construct a margin of error of 2% with 95% confidence? Use the prior estimate of P
times
0.2 for this estimate.
Proportion. So that one, to get the sample size. So N equals Z star over m squared. Oh no, okay, it's not that. No prior estimate, the formula is z star over 2m squared. Okay, that doesn't help me either.
So our Z is like 95%. That's 1.96. And the P star. Where's my lesson number?
So the question is, suppose you had been in charge of the sample size. P star equals 0.2. Prior estimate. So n equals 1.96 over. What was m again? What's m?
M is the 200. So not that one. Number 18 less than 17. Kitty, kitty, what's up, kitty? So if we have a prior estimate for P, namely P star, we can only plug this value into the equation above to compute the sample size required to obtain a desired margin of error.
Isn't this the one where it's like, you take the Z, which is that 1.96 thing for the 95%?
Yeah,
So it's 1.96 over the 0.02 squared times
the 2m.
I got 1537. 1537 is what I got.
So how did you do that? It's the formula.
Hold on, let me put in something where I can show you.
0.96.
1.96. M was 0.02. This divided by this
1.96 divided by
this.
you up to a little bit.
And what was the rest of it? 0.2. So 2 times 1 minus.
This is kind of the equation I use on my notes. I don't know where we found this, but it's legit.
Okay.
Times.
Like you do the 95% over the 0.202.
Mm-hmm.
Right, and then
Yeah.
you square that. Take that number and you divide times that by our P, which is the 0.2, and then you do the 1 minus point times that by minus 1.2, and then we round it up to the
To the next.
the next
the
number. So I got
so I
got 1537 is what I ended up.
I just finished it and I got the same answer.
Okay.
Okay. Whew, 29. Suppose you see the evidence that graduates of one of the top 10 business perform better than other investment managers. Conduct a hypothesis test. Which of the following pairs is the most appropriate for addressing this question? You want to see if there's evidence that graduates of one of the top 10 performs better than other people. So you say
Equal, not equal to?
no, they want to be better, so they want to be greater than, right? So you'd be
greater than.
Wouldn't it have to be the last one? It's the only one that has greater, right?
I think so.
That alternative's a little strange, but
So it's either, are they asking for the hypothesis, right?
well, the hypothesis and the alternate.
Okay, so it's either greater than or equal to.
The last one then?
Yeah.
Okay. Oops. Oh, I skipped one. Hold on. What requirements must be met to ensure that p hat is normally distributed?
It's the first one, right?
NP.
Well, that's for it to be a test statistics, right?
Yeah, it's the first one. It's NP is greater than 10 and N. Oh, which is that one?
Let's see.
Let's go back to our lesson.
Requirements. This is, we're still on one proportion, right?
Mm-hmm.
On one
That's
proportion.
lesson 17.
17.
Mm-hmm.
Yeah, on one proportion it says NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10.
Uh-huh. So that's
to be normally distributed though. That's the normally distributed, not the.
Oh, I don't know.
That's what it's asking about normally distributed. I thought, wasn't that the n equals 30 thing or no? I might be totally wrong. I might be misremembering with the last thing. Because I remember this was the NP is greater than or equal to 10 and whatever. I thought that was just to make sure it was valid.
oh, that's
Yeah.
our how to test it.
Okay, then I don't know.
But is the normally distributed different?
Let's see.
Maybe.
Well, they're both higher than 10. If you look at your data, the hypothesis test requirement, both greater than 10, yes, because it's 40. Confidence interval is higher than 10.
I think you're right. I think I'm just remembering from that old one. So I think it is the top one. So we'll keep moving. The value of your test statistic is what?
So we use the greater than. So your null hypothesis is what? The 0.2. So
Are we still running off of this old test?
I think so.
Now saying, so our test statistic is that? Hold on.
The z-score or the z.
Yeah. The 1.768. Is that what you
Yeah.
had?
That's what I got because I put a null hypothesis of 0.20 or 0.2 and then greater than.
P value is 0.039.
What I got.
Which is below, so we reject, right?
Mm-hmm.
Yes.
So then it's, I always get this confused. So we reject. So would it be that first one?
So reject.
Or is it no, I rejected it? Or is it the?
Well, we did reject HO, right?
So wouldn't it be the fourth one? No, I reject HO.
No.
So is there sufficient evidence? So
There
is.
There is, right? Because we rejected.
So
yeah.
Is it the one right below it? Yes, I accepted HA. Or is it yes, I rejected HO, the top one?
See, that's the weird thing. Don't they both mean the same thing?
That's what I think. But I don't think we ever talk about accepting the alternative, right? We talk about rejecting or fail to reject the hypothesis.
Yeah, so I guess probably the first one.
That's the safe answer to me, I guess.
Yeah.
34. Oh, yeah, that's a long one.
Whoa.
We have a download.
Download, that's the blue scores.
Wow, a lot of scores.
Oh, yeah. Hold on.
Comiendo.
Where are we on again?
What would this go into, though?
Oh, digo.
Just a sec.
No te molestes, Raquel.
Oh, my goodness. That's a lot. Okay.
Or does this go back out of categorical data analysis? Are we back into one of our single test kind of things?
This is the one sample t-test.
Yeah. I hate when they jump like this. Hold on. So we're back at a
Quantitative testing.
Yeah. Okay. And we're one sample t-test?
I think so, because there's only one set of data.
Okay.
Oh, did they give us the standard deviation?
They do.
Or the whatever that is.
They give us a whole bunch of stuff. They got a mean of 0.295. Standard deviation. They give us a standard deviation.
Hold on. What is? So the mean is 2.295. And we have 95% interval, which is the C star is 1.96. They're asking for the lower bound.
Lower, I got lower bound of, I could be totally wrong here. Hold on. M9. Yeah, hold on. I looked at the wrong thing. Hold on. 0.29?
And did you get the upper as 0.3?
Yeah.
That's what I have as well.
Okay. Just seems so.
Which testing did you guys use?
Single t-test? One sample t-test?
I think 290.
And the upper bound is 0.300. It says input the degrees of freedom. 99.
Yeah.
The test statistic.
Are you again?
I don't know if this is good, but I was dry outside.
That's a big T statistic. I mean, I should say negative.
Cosita.
Is your T? I got a 0 almost, essentially.
Yeah,
I got
mine must be wrong because I'm like negative 9,000.
So where do you on T? What is so hold on. So do we have a standard deviation or no?
I haven't put anything in.
Okay, so I have a mean of 0.295. We have the 0.95 confidence, a null hypothesis of 0.295, and type test of not equal to. Is that right?
Yeah. Does the null? What's the null supposed to be?
Null or the n?
Oh, hold
The
on.
null in between the confidence level and the type of test. Does that change anything?
Oh, I
Yeah,
put
it does.
0.295.
The null hypothesis is 0.295. That will change your t-test.
Yeah, so I'm getting like a 0 as well.
Yeah, I'm getting zeros. Like I even upped the decimals, and I mean it's zeros forever.
I'm getting negative 2.803.
For what? For the T?
Oh, you know what?
Para que lo hagas comando.
Yeah, for my T.
Thank you.
I'm not sure how you got that then.
So our T value is 0.
Can you try?
Mm-hmm.
Está duro.
Okay, something's weird. Because our p-value is 1.
Right.
No, mine is 0.006091.
Do not put the mean in the summary statistics. If you leave that blank, then my P goes to negative 2.803.
Yeah, you don't put the mean on the top. The summary statistics, you don't put anything on that.
Okay, so
In
you
all
take that
three
away.
spots.
Okay, then our confidence intervals go off different too.
It's 0.0293. What I got.
Yeah, I need to change that. So on the lower bound, it's 0.2.
Hold on, let's see.
And the upper bound is 0.293.
Yes.
And then the degrees of freedom is still 99, and the test statistic is negative 2.803.
Yes.
That looks a lot better. And the p-value is 0.006.
Yep.
You following, Sam?
Yep, I'm just putting it in really quick.
Okay.
Okay, I'm caught up.
What would you conclude at the confidence interval? So our p-value is way below the confidence interval.
Mm-hmm.
Sufficient evidence.
So we would say sufficient evidence that is different than 295.
Yeah.
For the top one?
Yes.
I like those ones that go quick like that. And then here's hopefully another quick one.
Okay, another download.
Oh, that's interesting. We've downloaded these numbers before. Because I just done and it shows a number 1 by. So we've done this before.
Oh, the height and PM, yeah, the PM and AM height. It's a paired t-test.
Yeah.
Because we're going to be getting the difference.
Never tried that before.
So, and the question is which one we put in.
Okay, so I put that in, test, You want your child taller.
Oops.
Lower bound I had.
AM minus PM. So AM would be the first one.
The first one, yes.
So I got 8.728.
I'll be there in a second.
Yep.
I'll leave mine up so you can look. We can look at them.
Oh, Control Z.
What's being asked?
Upper lower bound test statistic.
Okay, so
728.
Interesting.
Is that what you got?
Do we have a mean though, or do we have an alternate hypothesis, or not really?
Let's see.
Does it really matter?
To determine if the children are taller in the morning than in the evening. So,
But there's no value. We can't put anything in the null hypothesis for values, right?
No. test is not equal to?
But it doesn't change any of the numbers, so that's fine. The only thing that's weird to me is my p-value I got is zeros.
P-values.
I got 2.79468, and then there's a E, blah, blah, blah.
For the p-value?
Mm-hmm. What is the confidence interval here? 95, yeah.
Yeah, I didn't get that.
So the null.
But the null hypothesis, I just have 0 because it doesn't really tell you, and it doesn't. That'll change your test statistics. That's where I don't know what you put there, right?
And then your lower, we get the same lower bound and upper bound.
Well, but the problem is the null hypothesis and the type of test is gonna change your t-value and your p-value, but they don't really tell us what that is.
Well, if it's, they're asking for, hold on.
No, I get what they're asking, but I'm saying what do we put for the null hypothesis?
That's 0.
Okay.
And then they're asking for your test, that type of test is
Paired sample t-test.
but is it not equal to or greater than or less than?
Well, that's not going to affect our numbers. That's just going to affect if we reject or don't reject. The only number that affects is the p, but that'll take it from 0 to 1, which doesn't seem right.
So if it's not equal to the morning and the evening.
Well, the question is it greater in the morning? So would that mean it's greater than?
Okay, so if that's greater than, that's my p-value is 1.39734 with the E plus 24.
Okay.
Or minus 24.
I'm not sure how you get that because I get a 0. You can look. I mean, I'll pop mine up, but I'm
Okay.
confused why we're getting different answers.
Okay.
Okay.
1.5.
Do you see anything on there that looks different than yours?
Let me see. We got the same 41, 22, 4. Our t-test is the same. Our degree of freedom is the same. We got the same information. 12. 95. We get the same information, but our p-value is different.
Yeah, so that's where I'm confused. What about you, Sam? Have you put yours in?
12.
Yeah, I have, it's an E number, and it's a negative E number, so it's really, really small. I have 1.39734 E to the negative 24th.
Oh, we got the same one.
So mine just might be rounded. I mean,
Maybe.
but why? I mean, you can see how there I go. Now I get some numbers.
Yes, you have the same number. Just for some reason, it's not, because that is our number. Just
So mine's
for some
round.
reason,
So essentially, it's 0. I mean, essentially, it's 0.
yeah, I mean that comes out to be a 0.
You guys just might have scientific notation on or something. Okay, so I guess it's 0. I guess that's our p-value is 0. So then I mean, so based on this test, is there enough evidence to suggest that children are taller in the morning than they are in the evening?
So yes, because we rejected the null.
Okay, let's see where we're at. We can chat. We can chat forever. Or we can just see where we're at.
Oh,
That's a long review.
it's supposed to be easier Thanksgiving week, isn't it?
You got the first one right.
Yes, I love it.
We only missed 3. That's good. So 0, it was yes. So let's see what we missed. We missed number 29.
9.
Okay, well, let's see. What's 29?
Number 21. And number 18.
18, 21, and 29.
Yeah. And they're all questions about like hypothesis and stuff. So, which is interesting. So none of them are calculation. They're all questions.
Well, I wonder if like 18, I wonder if we're just backwards. I wonder if the
18.
null,
It's
like I wonder if our alternative is supposed to be the null and the null is supposed to be the alternative.
So that would be the top one instead of the second to last.
Yeah.
Okay. So let's have Sam be the next guinea pig. So Sam, let's have you do that.
Okay, 18. Now we have to fix 21.
21. So is there sufficient evidence the true portion of people with this illness? So we said yes. I failed to reject HO.
So this means we have to
Let's see if I can.
what's the question?
So yeah, you guys look into that for a second. I want to look at one thing.
For sure, it's a clue that your proportion of people who experience using about taking on control is different than the true proportion of people who experience using while not taking on control. So let's see. So if the alternative is the different, then
Or an acupril.
let's think.
So
if a new answer for 18 is the alternative is different, but the null is the same.
that's all a related question.
So I wonder if 21 would be the last one. No, I failed to reject HO.
That sounds logical to me because we know it's reject or fail to reject. So try that one. So try that.
Okay, so 21 and 29.
And then 29. So this one we were saying.
So you think we just switch that one?
So you think it would be like
the one right above it?
Sure, Sam. Try those and then report back.
Okay, let's try it. Submit. Okay. Those are all right.
Hey, look at that.
So number 44, we have the p-value as 0.0.
0, 0, 0, 0. Yeah.
Yes.
Okay.
Okay, hang tight. I got to get to these real quick. I'm just going to put the 3 that you have, and then I can do the rest on my own.
Are we able to, if I go out of this, are we able to go back and look at it later or no?
I don't remember. I just usually open up a new window.
What's your,
I'm just wondering for study purposes.
no, for your study purposes, you can go to your quiz and then click on the quiz number, and then there's don't click on a hover. It has a submission. You click the submission.
Okay, so the quizzes you can do it, just not the exams.
Not the exam.
Okay.
Okay, so which numbers did we look at? We had
I missed
10,
one.
21, and 29.
18.
Yeah.
I missed one.
And 18 was the last one? No, sorry.
Let me look at it.
18 was A.
Yeah, 18 is the first one.
Okay, and then what's the next one we got wrong?
21, which was the last one.
What's number 28?
28.
That was
1,537.
Yeah.
1,000.
537.
Okay. So no point, nothing. So 1537. Okay.
Yep. So you go to the nearest whole number.
Mm-hmm.
Okay, so I got 21. And what was the last one we did? 8 or something?
29, which that one was a second to last one.
Okay, so all right, so I can go through the rest on my own, unfortunately. Oh, so sad.
Well, I gotta redo mine too because I got one. Somehow I put the period in between. So
If you guys want, I can read them off to you while you're doing that.
I'm kind of surprised we got all the ones at the beginning right.
Yeah.
after all that pointing that we did.
I didn't feel very confident on those, but we.
Okay, let me see. Let me go back to my quiz. Oops. Just Louise. So number 2 is our
2 was G squared. The last one.
okay. This 1, 2, 3 is
The 2 proportions.
test of 2 proportion.
Yeah.
Okay.
The other day I was trying to do all these tests or quizzes
And then the other
on
one is
Friday, and the darn site was like half down, so I go like halfway through a quiz and then realize it wasn't saving anything, and then I had to redo it all from scratch. It was so frustrating,
that happens to me.
and it was like site wide.
Hold on, which one?
Not 18, wrong, number 19. I'm good, Sam. If you need it, if you want to go.
Yeah, we'll just do what we got from the previous one. If you want to get some sleep.
Okay. All right. Well, you guys have a good night then.
All right. Good night, everybody.
All right, bye.
Bye.